Now let's talk about something called statistical inference. Statistical inference is just the technical word for using data from a sample to reach a conclusion about a larger population. The reason why the word inference is used is because a conclusion that's reached about a population based on data from a sample isn't a proven conclusion. You can't use data from a sample to prove something about a larger population. You can use data from a sample to show evidence that something is true about a larger population, but you can't say that you've proven something to be true about the population, because whenever you use data from a sample to conclude something about a population, there's always a chance that a wrong conclusion will be reached. There's always a chance that even if you do a good job of running the study, there's always a chance that you'll end up getting misleading information from your sample that leads you to a wrong conclusion about the population. The reason why the word inference is used is because a conclusion that's reached about a population using data from a sample isn't a proven conclusion. An inference is a conclusion that's supported by the evidence or supported by the data, but it's not a proven conclusion, meaning it's not a conclusion that's guaranteed to be correct. And the following are the two most basic types of statistical inference. One basic type of statistical inference is using a sample mean to estimate a population mean. In statistics, the word mean just means average, so a mean and an average are the same thing. To calculate a mean, you add all of the values and you divide by the number of values. As a researcher, I might be interested in estimating the mean hours of sleep in the college student population. So if I wanted to actually calculate the average number of hours that college students in the US sleep per night, I would have to actually ask all 20,642,819 college students in the US how many hours of sleep they're getting, and then I would have to average all of those numbers. That's probably not possible. I can't collect data from all members of that population. But what I can do instead is select a sample of maybe a few hundred college students who live in the US and ask the people in my sample how many hours of sleep they're getting per night. I can then calculate the average or the mean of the people in my sample to estimate the mean of the entire population. I can calculate the mean hours of sleep that the people in my sample are getting to estimate the mean hours of sleep that the entire population is getting. And the mean of my sample isn't going to be exactly equal to the mean of the entire population. My sample mean is probably going to overestimate the population mean or underestimate the population mean by at least a little bit, because any value that you calculate with a sample never perfectly estimates the value of the entire population. Another example is collecting data from a sample and calculating a percentage to estimate a percentage for the entire population. I might be interested in what percentage of the US college student population lives with their parents. In order to actually calculate that percentage, I would have to ask every college student in the US whether they live with their parents, and then calculate the percentage of people who live with their parents. So if I actually did ask all members of the US college student population if they live with their parents, and I recorded all of their answers, I could divide the number of people who say that they do live with their parents by the total number of people in the population and multiply the answer by 100, and that would be the population percentage. But I probably can't do that because I don't have time to collect data from all members of the population. What I can do instead is select a sample of college students who live in the US and ask each person in my sample whether he or she lives with his or her parents. And then I can calculate the percentage of my sample who say that they live with their parents, and then use my sample percentage to give me a rough idea of what the population percentage equals. If half of my sample, meaning 50% of my sample, say that they live with their parents, that would suggest that the population percentage is somewhere near 50%. Now, I can't say that the population percentage is exactly 50% because, like I said, any value that you calculate with your sample is always off target by at least a little bit. Any value calculated with the sample isn't going to be exactly equal to the population value, but a value that you calculate with your sample can at least give you a rough idea of what the population value equals. In order to reach an accurate conclusion about a population, you want to collect data from a representative sample. A representative sample is a sample that has the same mixture of people as the entire population. So if the mixture of people in the sample is the same as the mixture of people in the entire population, then the sample is representative. And the reason why you want to have a representative sample is because the more representative your sample is, the more accurate of a conclusion you'll reach about the entire population. In other words, the closer the mixture of your sample is to the mixture of the entire population, the more accurate of a conclusion you'll reach about the entire population. Here's an example of why it's important to have a representative sample. If I'm doing a political poll and I want to know which person is likely to win an election, and I'm surveying people in the population, asking them who they're planning to vote for, I'll want the percentage of Democrats and Republicans in my sample to be close to the percentage of Democrats and Republicans in the entire population. For example, if I know that the entire population is 40% Republican and 60% Democrat, I'll want my sample to also be 40% Republican and 60% Democrat. I'll want my sample mixture to be the same as the population mixture so that I'll reach an accurate conclusion about who's likely to win the election. If my sample is not representative, meaning if it includes too many Democrats or too many Republicans, I'm not going to reach an accurate conclusion. If my sample includes too many Democrats, my results will make it look like the Democrat is probably going to win when actually the Republican might be ahead. If my sample includes too many Republicans, my data will make it look like the Republican is going to win when actually the Democrat might be ahead. But if my sample includes the same mixture of Democrats and Republicans that the entire population has, then my sample will give me an accurate idea of who's likely to win the election. Here's another example of a representative sample. If a university is 20% freshman, 30% sophomore, 35% junior, and 15% senior, a perfectly representative sample would also be 20%, 30%, 35%, and 15%. If the sample happens to have 100 students, then the sample would have to have 20 freshmen, because that's 20% of the sample. It would have to have 30 sophomores, because that's 30% of the sample. 35 juniors would be 35% of this sample, and 15 seniors would be 15% of the sample. So if my sample of 100 people from this population included these numbers of people down here, then the sample would be perfectly representative because the sample percentages would perfectly match the population percentages. The mixture of the sample would be exactly the same as the population mixture. I said that this would be perfectly representative, so the further off these numbers are from what we see here, the less representative the sample will be. For example, if this was 19, if this was 32, and this was 37, and this was 12, the sample would still be pretty representative, but it wouldn't be perfect because it wouldn't be, it would no longer perfectly match the population. Now, if these percentages were way off, like 90 freshmen, 2 sophomores, 5 juniors, and 3 seniors, that would be a highly unrepresentative sample because the mixture of the sample would be way off from the mixture of the population. So no sample is perfectly representative, but you want your sample to be as representative as possible because the more representative your sample is, the more accurate your conclusion about the population will be. And there's things that you can do ahead of time when you're planning your study to increase the likelihood that you'll get a highly representative sample and that you'll reach an accurate conclusion about the population. One thing that you should do if you want to get a highly representative sample is use random sampling, because random samples tend to be more representative than non-random samples, especially if the sample size is large. Therefore, random samples tend to provide more accurate information about the population than non-random samples do. That's because they tend to be more representative. But why do random samples tend to be more representative than non-random samples? It's because random sampling gives all population members an equal chance of being chosen. And when all population members have an equal chance of being chosen, you tend to get a wide variety of people in the population, and you tend to get a balanced mixture of people in your sample. The reason why non-random samples tend to be less representative is because non-random samples often come from one convenient location, such as a subject pool, and people who are at the same location tend to be similar to each other. For example, a subject pool includes all general psychology students, and almost all of those general psychology students are freshmen and sophomores. So in general, the following is true. Non-random samples tend to be the least representative. Small random samples tend to be more representative, and large random samples tend to be the most representative. But this is a little bit oversimplified because if a random sample is very small, it's not going to be very representative or accurate, even though it is random. Also, there are things that can be done to improve the representativeness of non-random samples. One thing that can be done to make non-random samples more representative is using quotas. For example, if I'm selecting people non-randomly, I can still set targets for how many of each type of person I would like to have. For example, I could say I want my sample to include 25 freshmen, 25 sophomores, 25 juniors, and 25 seniors. In that case, I've set a quota for different grade levels. Or I could say I want my sample to have 30% of this major, 20% of this major, 10% of this major, and 40% of this major. By setting those targets and reaching those targets or those quotas, I can make my non-random sample more representative of the population. If you want to use quotas, what you have to do is you first have to find out what the population percentages are, and then set a quota for your sample to match those population percentages. And that can be difficult to do because you typically don't know what those population percentages are. So I said that quotas can help you get a more representative sample, but it's actually often difficult to do because you don't know what the population percentages are.